Okay, today we're going to start talking about inheritance. This isn't about kind of what you get from your parents or anything, but it's kind of like that. It's the idea that, well, we'll see what that idea is. We'll talk a little bit about this thing called protected visibility. The book's examples on this are a little unfortunate, but I'll point that out. Protected visibility is something that we will not be using in this course so much because in the context of things that we do here, it's less, it just doesn't come up as much. However, in the simulation course, it turns out protected is actually a very useful thing for a number of reasons. I'll start talking about this super thing, which is not the strange Ukrainian guy who lives in the basement, but the reference to the superclasses. That is so, and we'll talk about overriding methods. We've already seen something called overloading methods, and then overriding methods is something similar but different. And it's important to understand the difference, and hopefully after this you will. So the idea of inheritance, it kind of goes back to a almost mythical phrase that was used when object-oriented stuff came out called reuse. And what they noticed was that in a lot of situations, you were kind of writing the same code again and again and again. The problem with that is not so much that you don't want to write the same thing again. It's just if you are trying to implement the same functionality and you're writing it again, then it's kind of like a game of telephone where every time you try to write it again independently, something is going to be off a little bit. So the optimal number of times that a particular function, I mean that not in the specific sense, but by function I mean just sort of a particular piece of logic that does something. The optimal number of times that is written is 1. Because if you write it once, if it only exists in one place, and you're trying to debug the thing, and it's not working the way it was designed, then there's only one place to look. If the same logic is implemented in 10 different places, and all of a sudden it's not working right, you have 10 different places to look. So let's say you find one of them that's the problem and you fix it. Well, there are still 9 other ones that are incorrectly implemented. And Murphy's Law says you're going to miss at least one of them. Whereas if there's only one, then, and you fix that, then job's done. Sorry. So their solution to that was to have stuff in, say, a parent class that would implement something which was common to everything that the specific subclasses would use, and then have the subclasses then specialize it. We'll see an example of that. And again, the terminology is not so important, but the parent class, superclass, sometimes they're called a base class. Base class actually has a little bit more of a specific meaning, but these are all essentially synonyms. Child class or subclass, those are synonyms as well. So the idea is that the child and this is asexual reproduction, the child inherits all the characteristics of the parent. So it has all the methods, all the instance variables, and everything in it. Now, when you get to visibility, it can be a little confusing. Specifically, if the, okay, so here's a way of here's an example of inheritance. In UML, they have this little kind of open arrow. And this is the ISA relationship. Again, the terminology is less important, although ISA is a good way to think of it, because in this particular case, in a program which is going to have various types of vehicles, you might have cars, you might have motorcycles, you might have trucks, each of which share a common set of characteristics, that is instance variables, and a common set of behaviors, that is methods. And those you would put in the superclass, and the subclass, you would put things that are special to it. Now, what's a little potentially confusing is this. If the vehicle has any, in this case, if the superclass, if the parent class has any private stuff in it, and so if it has instance variables, they're supposed to be private, although when we talk about protected, that's an exception. But the car, the subclass, will actually have those instance variables, but they will not be able to access them directly. In other words, if the vehicle has, say, something like a private double speed, then the car will have that instance variable, but the car will not be able to directly access that. It can't read it and it can't write to it. The only way the car could see how fast it was going is if the vehicle provided a getter method. So if the vehicle had a getter method, the subclass, the car, could access that getter method and say, how fast am I going? Get speed. If the car wanted to change speed, it could not say speed equals whatever, even though it has that variable is in there, but the car can't see it directly. So the only way the car could change speed is if the vehicle had a method, had a setter method. So if a vehicle had set speed, the car could say set speed. Why? Because the setters and getters have public access, and the car is like any other class. Okay, so that can be a little confusing when you're actually writing stuff, because if you could subclass something, there could be something in the superclass that has private access, and it's there, but you can't see it. So it's important to understand that it's there, it's just you can't see it. Now the subclass, the derived class, can add new variables, it can add new methods, and it can even potentially modify the inherited ones. The caveat on that is it can only modify ones which have public access. If the superclass defines a method to be private, remember we saw some private helper methods, then again, anything private cannot be seen by any other class, period, even an inherited one. Okay, so this is the magical phrase that they were using in the late 60s and early 70s and beyond. And that's software reuse. So what they notice is that in the older paradigms, whenever you wanted to change something, you had to make a lot of changes. And they wanted to be able to, okay, if I just want to change a few things, but maintain the old ones, then that's what they called software reuse. In other words, I can reuse the things that I've already done without modification. See, here's the thing. Editing code is like surgery in that there is no such thing as a trivial edit. So once you have a class which is doing everything it was designed to do, has been thoroughly tested, and has been verified to be correct, then you shouldn't touch it. Because like surgery, there's no such thing as a trivial edit. If I wanted to add functionality to an existing bit of code, and I have to edit that file in order to do it, then, again, like a supposedly trivial surgery, there is a chance I could screw up what I've already done. If I simply do not touch that code again, then it's going to be exactly as it was. And if it was perfect, then, you know, there's only one place to go, and that's down. Okay, and that's so a big push of this object-oriented thing was the idea that, well, we can extend functionality without having to touch the original code. That's the inheritance idea. Okay, so how do you do it? Well, you use the keyword extends. So in this case, this is an implementation of this UML diagram. So car extends vehicle, and that's how you would write it. So car presumably is an existing class, and if we're writing a new one, we would say car extends vehicle. Now the book has some questionable examples on this. So let's, well, okay, so although what they wanted to do is they wanted to give a really simple example, and this is not too bad. Here's where in my opinion, they wanted to illustrate the protected thing, so they made this protected. This really should be made private. Why? Because you have a setter and a getter. Whenever you have a setter and a getter, then the variable itself should be private. So this is where I disagree with the authors, although, you know, they're the authors and I'm only the instructor, but since I'm the instructor, you have to listen to me. Okay, so here's a class, book. It has a single instance variable, pages, and it has just a setter and a getter for it. Okay, so it's kind of leaving out leaving out a few things, but that's okay. So here what they're saying is that, okay, a dictionary is a book. And so what they're saying is, well, in addition to the book, the number of pages, we're going to have the number of definitions. And again, they have a setter and a getter for that. They make it private. So when you have an instance variable that's private and you have a setter and a getter, then you can keep it private. We'll talk about why protected is there in a little bit. And so what they add to the book method, in addition, so The dictionary has pages, and it has set and get pages, and it adds definitions as another int, and it adds this method, compute the ratio, which is the ratio of definitions to pages. Okay, so now they made pages protected so that you could perform this operation. But this would be better done if you would say get pages. I mean, well, I say better. It would have the same effect, but if you defined pages to be private, you could not write this statement because pages would not have access. You couldn't see. Dictionary has pages in there, but it can't see them because it's locked tight. A better way to do this when you are accessing instance variables in a superclass is to use the getter method. That's why they exist. Okay, so definition setter, getter, again, being private, it doesn't matter. Okay, so what is this protected thing? Okay, private, okay, means that only the defining class has access to that thing. And that thing can be either an instance variable or an instance method. So if you say private, in this case, say private definition, then only instances of the dictionary class have access to this variable. And if pages were defined to be private, only the book class itself would have instances of that would have access to that, not instances of the subclass. So the thing, what the authors I think are trying to show here is that sometimes you want the subclasses to have access to the instance variables in the superclass. And if that is the case, you can define them to be protected. And if you define it to be protected, then it can be directly accessed in a child class, as this example was. And again, private visibility cannot be referenced directly in a child class. Again, public instance variables are a no-no. That's if there's a mortal sin in object-oriented design, that's it. So that's where protected comes in. Protected allows the child class to reference the variable in that class. So it's not as sort of tightly locked up as private. This is where I think I kind of disagree with the Java developers on this. They also give it visibility to any class in the same package as the parent class. So this is an example where the language will allow you to do something that you should not. That is, if you define a variable to be protected, then any other class in the same package can also directly access it. And to me, that's also a violation of encapsulation, because I have a stricter view of encapsulation than the Java developers in this area, because to me, protected should only allow access in the child classes, but nobody else. Allowing classes outside of that hierarchy is to me a violation of encapsulation. Well, it's for the first example, they did it in order to illustrate protected. In other words, by defining pages to be protected, that's what allows them to do, oops, where'd they go? That's what allows them to do this. So let me erase my comments. Okay. This is possible only because Pages was defined as protected. In this particular instance, it's not the best design. So, but it's an illustration of using protected. Now, if you're asking about what I was saying here, this bullet point points out that if you that protected Pages instance variable could be accessed by any other class in that same package. And that's a terrible idea. Now, the whole purpose of encapsulation is, well, it's embodied in the word capsule. You know, think of a capsule. A capsule keeps everything sort of tightly inside of it. And so letting other things see your data directly allows them to muck with it. And that's not a good idea. So in the next class, we will be using protected a bit more because they're the convention for defining what are going to be called state variables. So even though this is an example where even though the language lets you get away with it, you shouldn't. It's like the Java language will let you define classes in an unnamed package, but that's a bad practice and it should not be done. Likewise, Java allows protected variables to be accessed outside of the class but in the same package, and that should never be done because that's a violation of encapsulation. Encapsulation ideally means that only the class that you're talking about has access. And in the case of subclasses, there are some situations where you do want to have access to it. Some. Okay, so the class diagram looks something like this. They like this little hash thing for protected stuff. For what we do here, that isn't going to come up, so you're not responsible for these particular, the pluses and the minuses. So they put the minus means private, plus means public, and the hash sign means protected. In the UML, any UML I show you will be more Java-like. So it might, if I were to do this, I might say int Pages. Sorry, drawing with this thing is not my forte. So if I were to say int Pages like that, and then it would be I don't know what that is. I would say void page message, whatever that is, and then this would be book. Writing text with the mouse is not the easiest thing in the world. Okay, I wanted to show you, here's an example that shows why inheritance might be a useful thing. Okay, so here we're modeling a family of instruments in at least some of them. So what these are this is an enum. So there are 4 families: strings, brass, woodwinds, and percussion. Here they're different instruments tuned to different pitches. So most of the orchestra tunes to an A440, but things like trumpets and clarinets tune to a B flat, and French horns tune to a low F. So the idea here is that this would be in a program that would be modeling these some of the different instruments and just having them do different things programmatically. They're, you know, in a, it's a little bit beyond the scope of this class, but it would be kind of in certain situations like, in a music writing piece of software that I use a lot, you know, you write the notes and everything, and then I can specify an instrument, and then it plays them as if, and it's kind of synthesizes the instrument. It doesn't sound exactly like the instrument, but approximately. So if I set a particular piece to be a trumpet, it'll sound sort of trumpety, and if I set it to a violin, it'll sound violin-y kind of. But this would be, you know, under the hood, could be something like this. So here's the idea, is that when you're designing something like this, and the design of this is a little bit beyond what we're going to cover here, but it's important to understand that. The idea is to take, you know, when you're kind of looking at these aren't a law of nature, but in this particular case, I want to represent at least these 4 different instruments: violin, cello, trumpet, and French horn, you know. So the idea is that all of the things that are common, so the things that I'm trying to represent, are best done in one superclass. This would be the base class, or the parent. So here I'm calling it instrument, and what does an instrument have? It has a family, which is this enum here. So it's either a string should be string, brass, woodwind, or percussion, and it has a tuning note. So those are the 2 instance variables. It has the constructor you'd have to tell what family it is, and all of the subclasses would have a tune method that you could play, and then another method that says play a note. Okay, just obviously in a full-blown application there will be a ton more. I mean, in classes that I write for my sponsor, I mean, I've had classes with lots of stuff in them. So, but all right. So the violin, for example, it has, see the play method, it overrides the play method and plays what it does. But in addition to that, you can actually pluck a violin, or you could bow a violin. And those are things that you can actually do on a cello as well, but not on a trumpet. So a trumpet doesn't, you don't pluck a trumpet. You can't bow a trumpet. If one of these was a guitar, you could actually bow a guitar. At least Jimmy Page did, but that's another. And likewise with the French horn. Now, actually, as part of the design, one might look at this and say, well, gee, there are some common elements between the violin and the cello, and if we also had a double bass and a viola, there would be pretty much common things there as well. So that would suggest possibly another subclass to bring all those common things together, but that would be the next step. Okay, so hopefully this gives a little bit more of an idea of, because you're probably thinking, why bother with this? Who cares? I mean, why not just write everything out at once? The idea here, though, is that there's functionality in the base class that is inherited by all of the subclasses, and all of the public stuff, and protected for that matter, has access in the subclasses. The private stuff is there, but they can't access it. Okay, so, however, what you can do is you can access stuff in the superclass directly. Now, it's important to kind of understand how this works with respect to constructors. So constructors are not inherited. That's with a little bit of a caveat on that. But level 1, constructors are not inherited. So in these subclasses, I should actually have put in a specific constructor for this. I should have said violin family, cello family, trumpet family, etc. But I didn't. I should have. Okay, so the way that the Java virtual machine, when it runs, creates the object is this. Well, the first thing to remember, every class has a constructor, period. And that may sound like duh, but in languages like C++, that is not necessarily the case. In C++, not every class has a constructor. You have to actually put it in. In Java, every class has a constructor whether you put it in or not. And that can lead to some confusion, but just remember that. Every class has a constructor. So how does Java create the class? If I say new, like if I were to say new trumpet, assuming that I had a trumpet constructor, I can't say new family if I want to make a trumpet. Why? Because if I say, I can't say new instrument. If I say new instrument, that will only give me this stuff. If I want the things in trumpet, I have to say new trumpet. So how does it construct it, though? Well, first it calls the trumpet constructor, and then it calls the constructor in the superclass, and then finally, it turns out, and the language is very confusing, but you have to kind of bear with it. The granddaddy, or grandmother, depending on of all classes, is a class called object. Okay, so that can be a little confusing. Every class is a subclass of a class called object, which is in Java. So when it's constructing an object, say trumpet, it will call the trumpet constructor. The trumpet constructor will call the instrument constructor then when it's done. And the instrument constructor will call the object constructor. And that is the first call in every constructor. The first call in every constructor is a call to either super or to this. Okay, we'll talk about this another time. But for now, just think of if there's only one constructor, the very first call in that constructor is a call to the super constructor. So the trumpet constructor would call the instrument constructor, and the first thing it would do is call the object constructor. And when the object constructor is done, it would go back down to the instrument constructor and then finish whatever the instrument constructor was doing. And when it was finished, it would go back down to the trumpet constructor and finish what it was doing. Okay, does that make sense? Maybe? maybe you want to see it in code.
Yeah.
Yeah. Let's see. I'll show you an example tomorrow. So if that's still a little vague, don't worry about it for now. But I mean, try to keep that in mind because it's important for a couple reasons to understand what's going on. Because some of this is hidden. And I think some examples will. Okay, so you can reference the immediate superclass using a keyword super. Now remember we've seen the this keyword. This refers to this object, which again is a terrible name. When you see this, maybe think self, which is a better word. Super is actually a descriptive word, because super refers to the superclass. So in this, if I'm in the trumpet class and I want to refer to something that's in the instrument class, that's been defined in the instrument class specifically, then I can say super dot whatever. And that comes into play when you're overriding methods. Okay, so this is a terrible example. Is this? Or wait, no. This one's not too bad. Let me see what. Why did they have? What was this? Oh yeah. Okay. Yeah. So no, this is a good example. All right. So they kind of fixed it up. So here's our book 2, and it has a constructor that says, okay, instead of fixing the number of pages, you have to tell me how many pages there are. Now, what would be a little better is if they kind of check to see whether the value that was passed is in fact a positive number. So if I say, here's a book with minus 52 pages, then what the heck is that? But never mind. Okay, they have setter and getter. Okay, here's the subclass. Okay, so this is a good example. So we're going to say this dictionary is going to specify how many pages and how many definitions. And notice this call to super here. It calls super and then passes num pages. And what that will do is that will call this constructor, and it will work because it's passing an int. And num pages wants an int. Job done. The confusing thing is that if when you're writing this, if for some reason you leave this off, then you will get one of the most confusing messages around. Let's see if do I have time?